Hello everyone and welcome back to InfoSec Train. I'm Rishabh Kotiyal, your Azure and Cloud Security expert. Today we have an exciting episode as part of our ongoing Azure interview question series. As always, we are committed to helping you excel in your Azure journey and ace those interviews. If you are new here, don't forget to hit that subscribe button and the notification bell so that next time you won't miss any of our free Azure and cloud security content. Now let's dive into the our next Azure interview questions. So how does Azure handle scalability and what are the best practices to ensure optimal performance? So scalability is a crucial consideration when it comes to the cloud-based applications, and Azure offer an array of features and best practices to ensure that application can handle varying workload while maintaining the optimal performance. Let's discuss some features. First is vertical and horizontal scalability. So Azure provide two primary approaches to scalability: vertical scalability, which is known as scaling up, and horizontal scalability, which is known as scaling out. So, vertical scalability involves increasing the resources such as CPU, RAM, and storage of any existing virtual machine to meet the demand of the application that require more resources. On other hand, horizontal scalability involves adding more instances of the application to distribute the workload. Horizontal scaling is ideal for application designed to run across multiple instances simultaneously. Second option is Azure Virtual Machine Scale Set. So managing the scaling onto multiple virtual machine can be complicated. So Azure gives you Azure Virtual Machine Scale Set, which simplify the process of allowing you to define a set of identical virtual machine and automatically adjust the number of instances based on the demand. So the dynamic scaling makes sure that the application can handle increased traffic efficiently. Third is load balancing. Load balancing is critical for ensuring that the even distribution of incoming network traffic across multiple instances, preventing the overloading of any single instance. So Azure Load Balancer and Application Gateway are essential components that provide traffic distribution and high availability, making sure your application can handle incoming requests effectively. Fourth is going to be the auto scaling. So Azure auto scaling takes the burden off developer by enabling automatic scaling based on predefined metrics or schedule. You can set up rules to dynamically adjust the number of instances based on CPU utilization, network traffic, and other performance matrices. This feature makes sure resources are provisioned as needed and optimize your cost and performance. Next is going to be the CDN and caching. So caching can significantly enhance applications performance. Azure offer caching solutions like Azure Cache for Redis and reduce the load on backend resource and improve application response time. Additionally, Azure CDN cache it delivers frequently access content from edge server located worldwide and reduce latency and improve your performance user across the globe. So apart from these, you can leverage managed services such as Azure SQL database, Azure Function, Azure App Service, and you can significantly improve application performance and scalability. So in conclusion, Azure offer a comprehensive set of tools, services, and best practice to handle scalability and make sure there is an optimal performance for your application running in the cloud. So when you use all these features, developer they design a robust, high performing application that can adapt to the changing demand and deliver an exceptional user experience. Now get ready for second question, that what is ARM, Azure Resource Manager, and what are its role in resource management. So ARM, Azure Resource Manager, is a critical component in Azure that simplify resource management and development by providing a unified and consistent way of managing and organizing resource in the cloud. So ARM act as unified management layer that abstract the complexity of individual resources. So instead of dealing with individual component like a storage account or network interface, user can work with resource at higher level of abstraction such as virtual machine, web app or database. This abstraction provides a more straightforward and cohesive way to organize and manage the resources. ARM, it also supports declarative template-based deployment. User can define their infrastructure as a code using ARM template, which are JSON file that describe the desired state of the infrastructure and relationship between the resources. This approach allows for consistent and repeatable deployment, making sure that the deployment are predictable, version control, and very easy to manage. So there is also the role-based access control model in ARM, which provide fine-grained control over who can perform action on a specified resources. So administrator, they can grant appropriate permission to user or group based on their role and responsibility, ensuring security and compliance. So ARM automatically manages resource dependency and orchestrate the provisioning process. When deploying multiple resources together, ARM handle ordering and timing of resources, create to avoid creation to avoid conflict and successfully deploy resources wherever needed. In summary, ARM play a pivotal role in resource management by offering a unified, consistent, and efficient way to provision, configure, and manage the Azure. In focus on resource, it focus on resource grouping, template-based deployment, RBAC, and dependency management, which simplify the management of complex cloud environment, faster automation, and enhance collaboration among the team. So I would say ARM is one of the best way of managing your resources when it comes to the governance, security, or cost efficiency, because it will allow you to work very effectively. Now on to the last question of today's video. Explain the concept of serverless computing in Microsoft Azure and how it can benefit application development. So serverless computing in Microsoft Azure is a cloud computing model where developer can build and run application without the need of managing the underlying server infrastructure. In this, the cloud provider, it take care of all the server provisioning, scaling, and maintenance, allowing developer solely focus on writing the code and building the application. The key concept behind the serverless computing is to use event-driven function, commonly known as serverless function. So these functions are piece of code that are triggered by specific event such as HTTP requests, database changes, or schedule time. When an event occurs, the serverless function is executed in response, and necessary resources are automatically provisioned for the function's execution. Once the function completes its task, the resources are released, and developer is only billed for actual compute time which is used. So there are some benefits of serverless computing in Microsoft Azure and its application development. We will discuss them. Like first is cost efficiency. With this, you only pay for actual execution time of your function, leading to the cost saving. In traditional server model, you will deploy, provision the resource, and then you have to pay for that whole server, and over the all time, which is while it was running. With the scaling, and second thing is scalability. So Azure Serverless Platform, it automatically scale your function in response to demand. Whether you have 10 user or 10,000, the platform dynamically allocate resource to handle the workload, ensuring optimal performance without any manual intervention. It simplifies management as well. So by offloading server management, the cloud provider and developer, they can focus on writing and delivering the business value only. It also helps in rapid deployment, as serverless computing allow developer to deploy the code quickly and efficiently. They can build small modular function that address specific tasks and easily integrate that into the larger application, promoting the best development practices. It also gives you the global reach. So Azure serverless computing is available in various regions worldwide. This enables application to be deployed closer to the end user, reducing latency and improving overall experience. So in conclusion, serverless computing in Microsoft Azure offer numerous advantages for application development, including cost efficiency, scalability, simplified management, rapid development, event-driven architecture, and global reach. So by leveraging the serverless function, developer can build responsive, cost-effective, and scalable application with reduced operational overhead. Now remember, all these answers were my wording. So you have to go ahead and change these answers according to your word, what you have understand with these videos and with this series. So this is a wrap for today's Azure interview question series. I hope you found the answers helpful and insightful. Remember, preparation is the key to success, so keep practicing and expanding your Azure knowledge. If you have enjoyed this video and want more Azure and cloud security content, don't forget to give it a thumbs up and share it with your fellow Azure enthusiasts. If you are new here, consider subscribing to InfoSec Train for more Azure free learning resources. Thanks for joining me today, and I will see you in the next video. Happy learning.